Today's video is the last one for section 1.3. We'll be addressing some of the word problems. It's about falling objects. So the homework in 1.3 is 101 through 104 all, 113 through 117 all. So on page 169, I'm actually going to go over one of your problems, 101. And it says that someone is standing on a cliff and they're going to drop something that is 1,000 feet from the ground. And so this is the position function. So S of t is the position function of negative 16t squared plus here's the 1,000 feet above the ground is what the object is. So S of t is the height in feet and t is in seconds. The other thing is that this object will have velocity. So the velocity of this object, the velocity in time, is the limit of S of a minus S of t all over a minus t as t approaches a. That's your velocity equation. At any time t, after 1 second, 5 seconds, 4 seconds, 10 seconds, you will know the velocity of the object. So v sub t is the velocity in t seconds, or in other words, the units is feet per second. The units in the position function is just feet. So if the question that is posed with this information is to find the velocity, this, of the object falling in 5 seconds. So that means v of 5. We're going to use this equation. But this says S of a. That means I need to use this equation. So I'll be going back and forth here. So I've set up this equation. So first I just found which equation I'm going to use. I want to use the velocity equation. Substituting for time is going to be after 5 seconds, and wherever I see, A, I'm going to put in my 5 seconds. I put in A here, put 5 in for A and 5 in for A, and the rest is the variable t. So let's go ahead and let's do this. So I have to now continue writing this properly. I have to go back up to this equation and put 5 in. Okay, so I just did S of 5, that's this one, minus, and then the original function by still using the variable t. All over 5 minus t. And again, if you look through direct substitution, that denominator is going to end up being 0. So hopefully we're going to be able to find a factor of 5 minus t in the numerator in order to cancel that out as one of our algebraic techniques. So let's see what we can do. Let's go ahead and distribute. Up here in calculus, sometimes you move rather slowly in doing all your math. Sometimes you go slowly, and you'll see what happens in these two problems. I'm going to go ahead and let's see, I can cancel out this. And I can factor out in fact, let's go ahead and factor out a negative 16. I haven't taken the limit yet, so I need to carry the limit through. So let's factor out a negative 16. And let's see what I get. I am going to get a 5 squared here, and I am going to get a negative 16 here. Oops. Not negative 16, negative t. There we go. And that is all over 5 minus t. Sorry, forgot my square. Apologize for that. So again, take out a negative 16 out of here. I got a 5 squared left, a negative 16 out of here. I got a negative t squared. Go back and multiply that through and double check. Okay, finally I've got that correct. I'm going to go ahead and go this way. I'm starting to run out of room. Again, I'm trying to find this factor. I kind of see it here. What that is the difference of two squares. So let's write that out. Let's factor it out. Right, there's my difference of two squares. There is my factor that I was looking for this whole time. I'm now going to be able to find the limit. First, let me clean up and see what I have left. Negative 16 times 5 plus t. Now I can go ahead and do direct substitution. I'm going to put in 5 for t. That's negative 16 times 10. That's negative 160 feet per second. That is the velocity of that object after 5 seconds being held 1,000 feet up in the air. That is the velocity. So the negative means downward. If it was positive, it means going upward, and that would not be for a falling object. Next problem. So page 69, 102. It is the same setup, that someone is going to hold a wrench 1,000 feet up in the ground and just drop it. So it's a falling object. Here's your same position function, and here's your same velocity equation. And let's see what the question is. When will the wrench hit the ground? When? That means they want me to find t, time. When? When will the wrench hit the ground? So, in other words, when is the height equal to 0? That's what it's really asking. So that means I need to use my position function, and I want to know when that height is equal to 0. So I'm going to go ahead and I'm going to set that equal to 0. Now this is what we've done back in Algebra 1 and Algebra 2. We have a quadratic, and we're going to solve for t, because that's what it wants. What time? What time will my position of my wrench be 0, be hit the ground? Oops, positive. And we're just going to leave it like this. You're allowed to leave some answers like that in calculus on the AP test. Now you know when you take the square root of both sides, this would be the plus or the minus. But because it's a real life situation, we're talking about time, I only want the positive one. I don't want negative time. That doesn't make any sense in the real world. So I've answered that question. I have another question to ponder from this. At what velocity, that means this one, does the wrench impact the ground or hit the ground? Well, we already know what time to put in, and that is this time that we just found. So I'm putting it into the velocity equation. There I go. I'm going to go ahead now and begin substituting that in. Now I'm writing the S of t. Just continuing to clean up this problem. Let's see, what do I want to do with this? I think I want to go ahead and distribute that negative again.
You have the set.